Bismillahirrahmanirrahim. Assalamu alaikum and very good morning to all. Welcome everyone. Today another day Friday session, and today's topic is about decision tree, and I am SAJJAD Rahman. Now let's start our today's agenda. In this session I will try to cover the introduction of decision tree, why it is popular, and the crucial part of this decision tree, the behind the math, and these important things are entropy, information gain, and GINI index. So the first thing first, introduction of decision tree. A decision tree is a like tree structure where is node represent a feature and the branch represent decision rule and the leaf represent the outcome. Okay, and this is very old and famous algorithm. This is used classification and regression. Also it is a supervised machine learning algorithm. We know that the supervised means whenever we train our model, we give both feature and label together as the machine learn from the label. So last week we talked about the regression. So we know that the regression uh, predict a continuous value. For example, this is our a regression model. If I give the data set, it can predict a number. We can see that there is a 100k heart sign, and in the classification we cannot predict any particular number, rather than we predict a label, how many are green, how many are red heart. So we can uh, achieved both regression and classification through decision tree. And in the last uh, week we saw that the regression represent only give us a continuous value. So why the decision tree is very popular? Well, uh, it is easy to represent, and we all know that the in our tree is like the in the ground there is the root, and this is leaf, and this is called branching. So these things, just if we reverse the tree, we can see that root in the top, the branching node here, and this is the leaf node. Easily we can represent. And the most of the decision tree are follow the binary classification, which means that each node has two branches and each has two, but in some cases it can more than three node, it's possible. So there is no way rule. So where the tree came from, or why it is popular? It's mimic the human thought. We can visualize that the branching is going there, if not going there, these things. So also the tree structure based on a lot of if else condition, like how if else condition. This is our root node. If the height is 100 centimeter, and if yes, then we can say it is definitely a male. If no, then we can check weight. If weight is greater than 80, if again there is an if condition, yes, if yes, then male, else female. So from here we can easily say that the decision tree based on a number of if else cases, and we can easily visualize and take decision from the pictorial view. So every algorithm built with the sum okay, every algorithm behind there is a math included. So we all know that the machine learning is built on the statistics, and statistics is strongly related with the math. So the three terms, entropy, GINI index, and information gain, we will see later how to calculate this mathematical term from our algorithm. uh, some resources we can say that some of uses entropy or some uses GINI index, and we can select any one from these, but for our session I will try to cover these two and this one. So this one or one and this one is must included, which will help how to take the next step. Entropy. What is entropy? Entropy is measure of randomness of a system. What is randomness? Come in our mind. Well, for example, I have a data set. All are circle. So there are lots of circle. If I uh, pick any one randomly, I can say 100% it is a circle. What if other cases, like I have a data set which inside circle as well as rectangle. uh, Sorry for the picture, I am not a good drawing. Okay, so here we can see that 50% circle, 50% rectangular. So we cannot pick any one and cannot say randomly that this is a circle, this is a uh, rectangular. There is the randomness, and this the things happen with us. How do we reduce? There are many way we can reduce or take uh, decision from it. Okay, so this is also called uncertainty. Randomness also called that there is no fixed. If we have like another one is a polygon, so there are three things. The lots of uncertainty means that the entropy is high, as entropy is measure of randomness. This is the formula of entropy. We will see later in our noteboard, and we will calculate from a data set how to find entropy. Okay, now we thank you for this presentation. Now we back on to the our one node. Well, and here how as already I am sure that the tree structure is about like this is node, this is called a branch, and it is itself, if we look closer we can see that here is a node, this is the internal node, and this is leaf. So this is our the main root entire data set here, and this is called decision node. This also a decision node, and this is our outcome or feature or whatever we can say. So this two is decision node, and okay, and we see that then our the find the entropy. Okay, for our simplicity I have uh, pick 5 data. Here we can see that there is an 3 yes and 2 no. So in our real data set there are thousand of data, so right now this is not good practice to pick thousands of data together. So if you clearly understand this, we can thousand or millions of data we can work, but manually this is not possible. That's why we help computation. So uh, from our data set we can see that there have 5 data, and among them 3 yes, 2 negative. Okay, so how do I calculate randomness with help of entropy? As we already know that the entropy is the measure of randomness. So this is our formula. So we are trying to insert this in our the formula. Okay, so first of all, what we have there is, we can see a minus sign, and this is summation I to 1. That means we have two, so I will maximum 2. And okay, now we try to calculate our randomness. So pxi, first of all I want these 3, but probability of 3, 3 yes out of 5, yeah, I give there. And then log, same thing, 3 by 5, but log base 2, and the rest of 2 negative out of 5, and 2 upon 5 log 2 to 5. Okay, if we calculate these things we will find, okay, just I am using a scientific calculator for easy understand. Wait a minute, 3 upon 5, this mean I got point 441, and you can check it. I can't use 0.528. if we together, this is 8, very bad handwriting. So oh, what's going on? Point 528, 0.441 is going to give there 969. So 969, this is very high randomness. Generally if there is a 2 class, which means that we can see that one is yes, another is no. So the random, if the 2 class, the randomness limit is 0 to 1. So the more you less near to 0, that means we have our randomness in our system very few. And if the value near to the 1, that means our randomness is high. So 0.96 is close to 1, so high randomness. If we pick any value randomly, we cannot say this is yes or this is not. So high chance it can be anything. So there is a term that called IG, information gain. Through or help this we can reduce it. Okay, and if we have more than 2 class, then the lower input is 3 plus, then and the maximum is more than 1. So just keep in mind. Okay, okay, so this is we can see the how to find an entropy of a system. This is very basic example. If we pick another one, we can see more value. Like this is an example. If I pick and for our simplicity I write this example, so I can also tell you that if in the first we took the target, here we can see that there is the 14 element. Okay, well, I forget to mention about that this is the golf data set, very popular for decision tree, everyone used for their first time practice, so I am not except from this. So I hope when you will practice we will show this. So if we look in our target value, we can see that there is the 14 rows, and among them there is 2 3 4 5 no. You can see that there is a 5 no and 9 yes. So I think you can easily find the index of target. So if we took another out feature like outlook, so how do we divide it? First of all, we calculate it that it's sunny. For example, we can uh, we can draw there is the outlook. So what happened, there is the outlook, we can say that rainy, sunny and overcast. So we can give sunny, rainy and overcast. This is our three things. I am saying you that how do we branching first. If we took an outlook, we are not pretty sure that this is the correct feature for taking, just for understanding I just tell you. So now we want to calculate how much sunny, 1 2 3 4 and here 1, this is 5 sunny. Okay, so we give there 5 sunny, and this is total number, but alongside we have to calculate when it is sunny. So this is yes, yes, but we found one no. Okay, one no, we found sunny yes, sunny no. That means this 5 we can found 3 yes, 2 no. If we now we look our second feature, second element, not second feature, sorry for that. So this is our, we pick rainy. So how much rainy are there? 1 2, we can find 3 4 and here 1 5. So 5 rainy, and this is similar with 2 y's, 2 yes, 3 no. This is similar, sunny and rainy both have 5 data and corresponding to their individual feature, and rest of are the overcast. And if we pick that the overcast is no, there is, oh, we can see that there is 4 yes value. Okay, 4 yes, 0 no. So how do we calculate our entropy? Well, this is the example of how do we, this is our formula, so we can simply just write it like uh, minus, I'm not showing the how to calculate 3 by 5 log 3 by 5. This is will be a little bit longer, but no worries, we will try to basically log base 2, and here we can write 2 upon 3 2 by 5 log I know that how you calculate the rest of the one, so I am not writing this formula again. You will find through this. Okay, if you are confused, let me know in the comment section after upload the video in YouTube. Okay, now we'll back here again after the GINI index. So how do we find the GINI index? So we already mentioned in our slide that we can use either entropy or GINI index. So how do we pick up GINI index? Let's say we select and yes, we give it a yes value. If we want, then we can give it yes, otherwise we do not give. Okay, no. So first of all, this is our feature and this is our hard disease. So our predict is to predict hard disease with the help of this. So what I have to do now, I have to write their chest pain, and if yes, then we can find no. If no, we can know this is okay. Okay, so 3 yes and 1 no. No, sorry. If it is yes, then what happened? Whenever it is no, we can found that there is no 1 and 0 y. Okay, but whenever it is yes, we can say there is 2 yes, 1 no values. So how do you find the GINI index for this? This is simply just we have to calculate 2 times. For the left node, what we can see that there is the 2 positive and 1 negative. So how do we calculate it? For left node, we have calculate it that total number is 3, and we can plus 1 by 3. Okay, we find a value, and okay, we can calculate this individually for our or together. If we give this is like here you can see the square value. Okay, give square, and after sum we can give -1, so we can give the value that is 0.66 square and -0.33. so we will find the 4.455. so this is left node. We similarly we must calculate our the right index. So this is simple. Total is 1 1 1, so we will find 1, and 1 over 0 is basically 0, so 1 minus 1, that is 0. Now we have to calculate these two. Okay, so total is GINI of left plus GINI index of right. So we give their um, 0.45 something plus 0. This is, so similarly we have to 0.45. This is not 8. Okay, so disturbing mouse to 45. Okay, and well, we can see that how do we find the GINI index. So similarly, if we check the blockade arteries, there we can see 3 yes, 1 no, and we will find this. So if we calculate other two things, we will find. And how do we pick the next one? So this is depend on the information gain. Okay, now back on the information gain. So we can if we remember earlier, we found 0.96 something in our randomness. Okay, here we can see that 96. So how do we reduce it? Our goal is to reduce this entropy, otherwise we cannot predict well. So the reduced entropy is called information gain, and here is the formula of information gain is the parent entropy over the child entropy. So how do we calculate this? Have you any idea? So first of all, we look in our in here we calculate the features outlook and we divide it 3, and for our simplicity I wrote this, that 5 sunny, 4 overcast, 4 out of 4 is yes, and rainy 5, 2 yes, 3 no. And in this we have to calculate our information with help of this example. So okay, let's start. This is our parent. So in our parent it's written this. How do I found? First of all, I can consider the target, and in the target I found 9 yes value and 5 no value. So this I consider the full data set based on start from this, and then we look feature one feature outlook. Based on outlook, how do we branching our decision tree? Okay, so first and foremost we can find this value is 0.94, but how do we apply rest of this? Okay, first of all we have to pick the sunny, and we already find the entropy of sunny. So if you forget, I just call you that you can go back and to see and find entropy of overcast. Okay, we can denote entropy for over h. Okay, and then entropy of rainy season, and then based on this we will find that this is 0.27, and then the answer. If you are confused about how to find h of s. Okay, I am taking the overcast. Here we can see that the entropy of overcast is nothing then minus